from rest with a uniform acceleration of 2 meters per second square, find the distance covered by the body in 2 seconds. The informations to be taken in that tabular form, in the data form you have to give. So you are having here, first column is called given. What it is given you have to write. What informations you are getting from this? It is saying a body starts from rest. Means body is starting from rest, means its velocity would have been 0 unit at the time of start. That is, u should be equal to 0 meter per second. Mind, 0 is also a quantity, so it must be associated with a unit, with its unit. Most of the time we write simply 0. We take it as granted that it is 0 of the unit, so nothing wrong if you write 0 with its unit. So 0 unit. It's saying the second line, uniform acceleration happens to be 2 meters per second square. So acceleration value, its acceleration is 2 meters per second square. It is there given. Also given there, the time taken for it is 2 seconds. They are asking you that the distance covered, that means to find S. So you have to select the formula for it. That what closest formula from the given data. That means you have to give expression. Expression is the formula what it is there to be done. So for expression, the second step, expression is nothing but the formula you are using. S is equal to ut plus 1 by 2 at square. It is an accelerated motion, it is said, so it is coming plus. And since this thing is started with 0, so the velocity will be increasing. So S is equal to this. Now this gives the value. After writing this, you have to input the values there and working. So the third step is the working procedure. How you are working, that is important. That is, S is equal to, U is already 0 meter per second, multiply with time taken is 2 seconds, plus 1 by 2 into, A value is 2 meter per second square, multiply with T square. So T is how much? T is 2 seconds. So you write 2 seconds square. As it is given there, you can, I'm just using it along with the units. But you can do without units, but at the end you must give the right unit. So working. So working should be shown. Working should be on. That is, multiplying 0, this will vanish. This will disappear. Whatever it is. So it will stand only 1 by 2 into 2 meter per second square into 2 to the 4 second square. The units will go cancelled. 2 and 2 will get cancelled. So you are getting the distance traveled is 4 meter. That's why your result, you have to declare the result. Result is distance traveled is equal to 4 meter. Write the answer here. It was asked. I did it a very lucid way, in a straight form. You will practice it. You can omit the units at present over there, but at the end don't forget to write the result with the words, because this is the part where it is ending the algebraic or mathematical work. It is not asked calculate S in your question, it is asked the distance traveled. So you must use the term distance traveled. How much you have to declare. So there will be these 4 steps: given step, the data, expression step, the formula you are using, the working procedure, simple mathematical procedure by the rule of BODMAS, because this plus and multiplication all are there. Maybe some bracket terms may be also there. So don't break the rule of arithmetic, basic principle of arithmetic. And then the distance traveled you got here, you may be finding some other things and also in the same format. Okay, you can do number 2 by the same method, because I am seeing the question number 2 is having it is given the u value as 10 meter per second, a value as 5 meter per second square. You have to find distance with the 5 second time, the same formula. So data is already given in your statement, and the formula you have to set and work out by the same method. This is specimen workout. Specimen workout. You can escape this given expression working these words, you can escape, but don't escape the sequence. Don't escape the sequence. Sequence must be maintained. That's why I use this term at first. I go for 4th question. A body initially at rest, again the same kind, starts moving with constant acceleration 2 meter per second square. Calculate the velocity acquired and the distance traveled in 5 seconds. It is also data, then formula for finding V, that value will be finding V, and finally the distance formula ut plus half at square. If you write the data will guide you which formula you are going to set. Any formula will be out of these 3, or maybe using 2 formula at a time, maybe using 3 formulas at a time. But these expressions are very important. The given line, the given part, that is the data form, if you write very correctly, the data will simply guide you how you work out the numerical problems. I come across, I do hope that you can work out these questions in a very simple way. There comes, a train moves with a velocity, question number 6. A train moves with a velocity of 20 meter per second, is brought to rest. Now it is not starting from rest. It comes to rest. It comes to rest after a start. That means its final velocity is indicating that the final speed also you can say that it indicates it is 0. Means it is stopping there. So it says a train moves with a velocity of 20 meter per second. Since it moves with 20 meter per second, so given part u is equal to 20 meter per second. Then it says that it is brought to rest, means its final velocity is 0 meter per second. The data. Then applying brakes in 5 seconds. So time taken for that is 5 seconds. Then after, calculate the retardation. Mind, it is calculating the retardation. Of course, retardation, there is no formula. You take out acceleration, from there you will come to know what retardation should be. Because formula is there with acceleration formula. The word is there, acceleration. Use the same formula, no problem. So here you are having u, v, t, find a. It is simply a will be v minus u, small v minus u by time. From the first equation only. That is a is equal to final velocity minus initial velocity divided by time. So what it should be? The final velocity, the working procedure, final velocity, a is equal to final velocity is 0 minus initial velocity is 20. I am just skipping the units for your clarity, divided by time happens to be called, it is 5. Now on top it is meter per second and down it is second. So here you are getting it as 0 minus 20 is minus 20 meter per second divided by 5 second. This 5 and 20 keeps cancel, that is 4. It is coming 4 minus 4 meter per second square. Obviously meter per second square is the acceleration unit, and acceleration getting this. Now what is retardation? Result should be in retardation form. Result. Retardation will be negative acceleration, that is minus acceleration. That means it will become positive, so it will be 4 meter per second square. Mind, if you miss this step, the last, that is from acceleration converting to retardation, you may be losing the marks. You'll surely lose the mark. So it is important that since retardation is asked, you have to declare the retardation in its own form. Though your full process is coming in a very much patterned way, but the declaration of result is important also, because it is asked there what the retardation value is there. It will be definitely a positive one. Question number 7. In your textbook, question number 7. I read and you work out with that. A train travels with a speed of 60 km per hour from a station A to station B, and then comes back with the speed 80 km per hour from station B to station A. Means once it is going, then it returns. But both the speeds are different. Both the speeds are different. For going speed from A to B is 60 km per hour, and for return speed is 80 km per hour.